Let's take a look at something called the discriminant. And so when we're working with quadratic equations, we've got this crazy thing called the quadratic formula. It looks something like this. And this magic formula called the quadratic formula can find the solution to any equation, any quadratic equation that is in standard form. And so this stuff under here is real important because this determines if we have a real solution or not. And real solutions to a quadratic equation are the x-intercepts on the graph. That's a lot of stuff going on there. So we'd like to know something about this, and that's called the discriminant. When that discriminant is positive, then we end up with two real solutions. All right, when that is negative, if we get a negative number from b squared minus 4ac when we plug in these numbers, then that means we'll have zero solutions, zero real solutions, that is. They'll be imaginary. And the real solutions, as we just mentioned, are the x-intercepts. If the discriminant comes out to be 0, which is not positive or negative, then we end up with one real solution, and these are the only possibilities for a quadratic equation. So that's what's going on, and what it corresponds to on the graph is this. If the discriminant is 0, that means we're going to have some quadratic equation, some parabola that looks like this. It just touches the x-axis at 1. If it is a positive, then we're going to have some parabola that crosses at two places. It's going to have two x-intercepts. If the discriminant is negative, then we're going to end up with something like this, where our parabola doesn't even touch the x-axis, all right? So those are the three cases we're looking for. Let's try some out. So here we want to determine how many solutions there are, what's the type and number of the solutions, and we want to determine how many real solutions exist, okay? And confirm your answers, all right? So what type of number, are they imaginary or real, and then how many are there if there are real? So, all right, so our discriminant, b squared minus 4ac, b squared minus 4ac, these are our a, b, and c values, okay? So a is 4, b is -3, and c is -1. So let's just plug that in. Watch out for those negatives, put them in parentheses. Those will cause problems. A is 4 and C is -1. So we work that out. That's 9. And this part right here is going to be, think of it as -4 times -1. That's +4 times 4 to 16, or 4 times 4 to 16 times -1. And it all comes out to be a +16. And so that's 25. Well, that's a perfect square. So when that goes under the square root, it's going to actually come out to be a perfect square that we can square root in the quadratic formula. So we will have two rational, which are real numbers, solutions, okay? So two rational and real solutions. It's rational because this is a perfect square. If it's not a perfect square, then the quadratic formula will get a square root and we'll have an irrational number. We can confirm that by graphing. If we graph this quadratic, y equals 4x squared minus 3x minus 1. This is the graph we get, and we're looking for the x-intercepts. There they are right there. Happen to be 1 and -0.25. These are rational numbers because they're decimals that terminate or repeat. Okay, so terminating and repeating decimals are rational numbers. Okay, so let's try this one. Different polynomial here, different quadratic. We got a different a, b, and c. So let's try it out, see what we get. B squared minus 4ac gives us 2 squared minus 4 times 5 times 3. Don't necessarily need those parentheses in this case because they're all positive, but it's a good habit to get into. And we've got 20 times 3, that's 60, and so that's -54. Well, that's a negative number, so since that's a negative number, we're going to have no real solutions, okay? No solutions at all, all right? Well, actually, they'll be complex imaginary numbers, but we have no real solutions. That's the key, all right? And if we graph this one, we can see that's true. When we graph this equation, y equals 5x squared plus 2x plus 3, we get this, and we can see down here that here's our x-axis down here. Actually, no, sorry, it's even farther down. It's off the page. But anyways, you can see we're at 4 and 2 on the y-axis. This thing doesn't even touch that x-axis that is somewhere down there, all right? So it's off the x-axis, no x-intercepts, no real zeros. Let's try a couple more. Again, we got our discriminant, b squared minus 4ac. So we got some bigger numbers here, so let's work it out carefully. We've got negative 24 squared minus 4 times 9 times 16. Big numbers here. Let's see what this comes out to be. And both of these come out to be 576, and that's going to be 0. So we have 0. That means we're going to have one solution, one real and rational solution. So one rational numbers are always real solution. Okay, and let's graph it to confirm that. So here we have our graph of y equals 9x squared minus 24x plus 16. And we can see that it touches the x-axis at 1.33. That is a rational number. It's 1 1/3. Okay, and it's because it's a repeating decimal. So we get confirmation there that we have 1, 0, 1 x-intercept. One more. Let's try it out here. We've got b squared minus 4ac. That's our discriminant from underneath the radical in the quadratic formula. 5 squared minus 4 times 2 times 1. And that's going to be 25 minus 4 times 2, that's 8. So that's going to be a 17. That's not a perfect square. So we're going to end up with two solutions, two real but irrational solutions. They're real, but they're going to be irrational because when you plug that 17 in to the radical in the quadratic formula, you'll get a square root of 17. Can't figure that out, right? Well, zeros or solutions. We've been calling them solutions. Let's use the same wording there. All right, so let's check that out with a graph. Let's see if we get two real irrational solutions. And here's our graph for this equation. And we can see, yep, we've got two zeros, that's for sure. They're real numbers. Real solutions make x-intercepts. And we have a crazy old decimal here. It's an irrational number. It's never going to end. It's never going to repeat, even though it's only showing 3 decimals here. That's obviously not repeating. This one over here is repeating. Repeating makes a rational number. Okay, so there you have it for the discriminant, b squared minus 4ac. Remember, that just comes from underneath the square root. And if that is positive, we have 2 real solutions. If it's negative, we got 0 real solutions. If it's 0, which is in between positive and negative, we get 1. All right? And those are the only possibilities for quadratic equations. That is the discriminant.